Hello students, welcome back to our channel Diksha Karnataka. So your COMEDK exam is approaching. So as you know, we have started a series where we are discussing the top 30 questions from all the high weightage topics. So in this video, we have come up with one of the most important physical chemistry topic, that is equilibrium, right? So we'll be discussing questions, formulas, important concepts. So you can expect easily like 2 to 3 questions from this chapter, and if you are able to solve these questions, the questions are covering almost all the concepts. So if you are solving these type of questions, you can assure that this chapter is ready for your exam COMEDK. Okay, so let us start with the first question here. Okay. The solubility product of BaCl2 is 3.2 into 10 to the power of minus 9. What will be its solubility in moles per liter? So this question from, we know KSP formula for any salt of type AXBY. The KSP formula is x to the power of x, y to the power of y, s to the power of x plus y, right? Now if you solve here, KSP value, barium chloride is a form of 1, so x is equal to 1 here and y is equal to 2 here, right? I can write like this. So 1 to the power of 1, 2 to the power of 2, and then we have s to the power of 1 plus 2, that is 4s cube, that is equal to KSP. So we need to find the s value. KSP value is given to you as 3.2 into 10 to the power of minus 9, and then we have divided by 4 is equal to s cube. So I'll get 0.8 into 10 to the power of minus 9, that is equal to s cube. So now if I take the cube root on this side, we'll get 10 to the power of minus 3 into 1. Okay, so the correct answer for this question is option number C. Now let us see the next question. For the reaction 2NO2 gives N2O4, Kp by Kc is equal to. So we have this formula, Kp is equal to Kc into RT to the power of delta N, right? Delta Ng. Now Kp by Kc will be equal to RT to the power of delta Ng, right? Now if you see here, what is the value of delta Ng? Delta Ng is number of gaseous products minus number of moles of gaseous reactants. So products are 1 and reactant is 2. So 1 minus 2 is minus 1. So I can substitute here RT to the power of minus 1, that is equal to 1 by RT. So the correct answer for this question will be option number A. Easy one. Next, for a reaction 2SO2 plus O2 gives 2SO3, 1.5 moles of SO2 and 1 mole of O2 are taken in a 2 liter vessel. At equilibrium, the concentration of SO3 was found to be 0.35 mole liter inverse. The Kc for the reaction would be. Okay. So this question I'll say is a like moderate level question, not a very easy question, little bit tricky question is there. So first see, let us write the reaction. 2SO2 plus O2 gives you 2SO3, right? Now what are the initial concentrations given? 1.5 moles and this was 1 mole. Now let 2x amount from SO2 has reacted. Then what will be left here? 1.5 minus 2x. And here it will be 1. So 2 moles reacts with 1 moles. So 2x moles will react with x moles. So from O2, x moles has reacted. 1 mole was there. So how many will be left? 1 minus x. Now you can see 2 moles of SO2 is producing 2 moles of SO3. So 2x moles of SO2 will produce 2x moles of SO3. Right? So I can write here 2x. So these are all moles. Okay. I am writing in terms of moles. Now, the question has given that the equilibrium concentration of SO3 was found to be 0.35 mole liter inverse. Okay, that means if I want to calculate the concentration of SO3, that will be the number of moles by volume. Number of moles is 2x and volume is 2 liter. So this value is given to you as 0.35. Right? So x value is 0.35. Okay. Now after this we can calculate the equilibrium concentrations of all the given compounds. So what will be the moles of SO2 at equilibrium? Moles of SO2 will be 1.5 minus 2x. 2x is 0.7. So that is 0.8. Okay. Next, moles of O2 is equal to 1 minus x, that is 1 minus 0.35, that is 0.65. And then we have number of moles of SO3. SO3 is, we can say 2x, that is 2 into 0.35, so that is equal to 0.7. Okay, these are the number of moles, but we need to find the concentration now, right? So concentration of SO2 will be equal to the number of moles by volume, that is 0.8 by 2, that is 0.4. Number of moles of O2 will be again 0.65 by 2. Okay, so we will get 0.65 by 2, and then I'll keep it as it, and then number of moles of SO3 will be equal to 0.7 by 2. Okay, now if we solve this, let us solve it. What we will get? Kc value you have to calculate, right? I'll write on that side. So this part I am erasing now. So if you see, Kc value we have to find out. So first we have to write the expression for Kc. Okay, so Kc value will be SO3 concentration to the power of 2 by SO2 concentration to the power of 2 into O2. Right? Now what is SO3 concentration? SO3 concentration is 0.7 by 2. Okay, its square. Then you have SO2 concentration is 0.4, so its square. Okay, and then we have O2. O2 concentration is 0.65 by 2. So 0.65 by 2. Okay, so now if you solve this, the value you will be getting here is 2.36. So the correct answer for this question will be option number A. Okay, so this question is little difficult one, so just try it, understand it properly. If you have any doubt, please ask in the comment section. Now coming to the next question. For a polybasic acid, the dissociation constant have a different values for each step. Okay, so the dissociation constant keeps on increasing, keeps on decreasing as we go successive dissociation. Now what is the reason for this? For example, you have an acid H3A, right? So once it releases one H plus, we form H2A minus, right? Now from H2A minus, if you want one more H plus, we will get H plus and HA2 minus, right? Now what is happening here? You see, this charge, this compound is already negative, and now you want to remove an H plus from there. So the negative and the positive ions have a strong bond. So removing H plus from here will be very difficult. So if the difficult means the acidity will be low, so Ka value will be low. So that is why the first Ka value will always be higher, then the second, then the third. So in this case also Ka1 will be greater Ka2 than Ka3. Correct answer for this question will be option number A. Now coming to the next question. Solid barium nitrate is gradually dissolved in 1 into 10 to the power of minus 4 moles of molarity of Na2CO3. So what we are doing? So just imagine the question, visualize the question. Barium nitrate is dissolved in a solvent containing sodium carbonate, right? Now what will happen? This will form barium carbonate. So at what concentration of barium 2 plus will a precipitate begin to form? So at what concentration of this one, barium carbonate precipitate will form? Okay, so what is the condition for precipitation? We know the ionic product should be greater than the solubility product. Now for ionic product of barium carbonate, so the formula for barium carbonate is Ba2 plus. This is the formula of the solubility product of barium carbonate, ionic product of barium carbonate. So that should be greater than the Ksp value. So we can write barium concentration we have to find out, right? And carbonate is coming from Na2CO3. Its concentration is already given to you as 10 to the power of minus 4. That should be equal to, the Ksp value is 5.1 into 10 to the power of minus 9. So what should be the minimum concentration of barium 2 plus? That should be equal to 5.1 into 10 to the power of minus 9 divided by 10 to the power of minus 4. So we'll get 5.1 into 10 to the power of minus 5. Okay, so the correct answer for this question will be option number B. Okay, this is very easy question. Next one. If Kp for a reaction A gas for 2B gas 3CD is 0.05 atm at 100 Kelvin, then its Kc in terms of R will be. So the question is again in the relation between Kp is equal to Kc into RT to the power of delta Ng, right? Now first let us calculate delta Ng value. Delta Ng, be very careful while calculating this one. It is the products, gaseous products minus the reactant gaseous molecules. So if you see, there are 3 here and 1 here. 4 is the number of products minus, in the reactant side we have 3. 2 here and 1 here. So that is equal to 1. So now what we can say, Kc will be equal to we have to calculate its Kc in terms of R. Kc will be equal to Kp by RT to the power of delta Ng is 1, right? Now, if I substitute, Kp value is 0.05 atm, so I can write it as 5 into 10 to the power of minus 2 atm, right? Then we have R should be is in R term, and then temperature is 1000 Kelvin, that is 10 to the power of 3, right? So now if this one goes up, we'll get 5 into 10 to the power of minus 5 by R. So correct answer for this question will be option number D. Now let us see the next question. 100 ml of 0.02 molar, 100 ml of 0.02 molar benzoic acid of pK 4.2 is titrated using 0.02 molar of NaOH. pH after 50 ml and 100 ml of NaOH have been added are. Very important question. Okay, please understand this question. We'll solve for 250 ml first added and then 100 ml is added. So first is, what is the reaction? The reaction is between benzoic acid. So benzoic acid plus NaOH will form sodium benzoate, okay, plus water. Okay, now what are the values given? For benzoic acid, if you know, molarity is equal to number of moles by volume. So number of moles can be equal to molarity into volume. If volume is in ml, we multiply 1000 here. So that means it will become molarity into volume by 1000. So I can write molarity into volume into 10 to the power of minus 3. So I will get the number of millimoles, right? So now if you see here, for NaOH, for benzoic acid, the molarity is given to you as 100 ml. Okay, I hope you are able to see. The molarity is given to you as 100 ml and the molarity is the volume is 100 ml and the molarity is 0.02 molar. Now if I multiply these two, I will get the number of millimoles, that is 2 millimoles of benzoic acid, right? So benzoic acid present in the question is 2 millimoles. Now coming to NaOH. So what is the concentration of NaOH given? NaOH concentration is given to you as 0.02 molar and initially we took 50 ml. Okay. Now 50, if you multiply, we will get 100, then we will get 1 millimole, right? So now, yeah, so this is 1 millimole. Okay. Now if you see, according to the reaction, 1 mole of C6H5COOH, that is benzoic acid, reacts with 1 mole of NaOH. Now 1 mole of, so I can say 1 millimole of NaOH will react with 1 millimole of benzoic acid. So this is initial, okay, sorry. This is the initial concentration that was present. Now what will be left after the 1 millimole has reacted with 1 millimole? Here we will be left with 1 millimole of benzoic acid. This one will become 0 and it will form 1 millimole of this salt, right? Now in the solution we have a weak acid and a salt of weak acid. So what does this form? If you remember, weak acid and the salt of weak acid will form a acidic buffer. So what is the Henderson equation? The pH formula of a weak acid, pH formula of a acidic buffer, right? pH is equal to pKa plus log of salt concentration by acid concentration, right? Now what is the value of pKa? pKa value is already given to you as 4.2 plus log of, what is salt concentration? The number of moles by the total volume. So total volume, how much we have taken? This one, C6H5OH was 100 ml and this one was 50 ml. So 150 total volume. So salt concentration will be your 1 by 150 and the acid concentration is also 1 by 150. Okay. So this one is same. So this one will becomes 1, log 1 will be 0. So what will be the pH value? 4.2. Okay. So we can eliminate these option now. 4.2, 4.2, 4.2. Clear? I hope this question is clear now. Now coming to the next one. If you feel after now 50 ml of NaOH, we'll get the first part. Now what happens if 100 ml of NaOH is added? So just we will change this part. Here what will happen? The number of moles. See, this 0.02 molar, but it is now 100 ml. Okay. So now 100 moles will be how much? We will get 2 millimoles, right? We will get 2 millimoles. So now in the reaction, what is present? We have this one is 2 millimoles. I'll take this one, I'll erase this part. Okay, so just a minute. This question is very, very important, conceptual based question. You should know the formulas, all the formulas we are using here. Okay, so now if you see, we have this one as 2 millimoles. Okay, this is now 100 ml, right? So now you see here, according to this, 1 millimole will react with 1 millimole. So 2 millimole will react with 2 millimole to give you 1 millimole or 2 millimole of the salt. So initially this was present. At the final concentration, this will become 0, this will become 0, this one will be 2 millimoles, right? Now what we have to do, you can see this is a salt, right? Salt and water, and this is a salt of weak acid and strong base. So what it will undergo? It will undergo salt hydrolysis. So we have to use the formula to calculate the pH of salt hydrolysis of a weak acid and strong base. So what is that formula? pH formula. pH is equal to, here you have 7 plus, okay, 7 plus half pKa, that is half of 4.2, minus plus half of log C. Log C is coming 10 to the power of minus 2, that is minus 2, right? So we will get 7 plus 2.1 minus 1, okay? So we'll get 9.1 minus 1, so that is around 8.1. So the correct answer for this question will be option number C, okay? So now let us see the next question. For a reversible reaction, okay, for a reversible reaction, if the concentration of the reactants are double than equilibrium, so you know equilibrium constant remains the same. When you double the concentration of the reactants, the product concentration also increases. The reaction goes in forward direction to maintain the equilibrium. So that is why it remains same. Okay. Now question number 9. For the reversible reaction, A plus B gives C plus D. The delta G value is also given. Which one of the following statements is true? The entropy change is negative. So if you see, there was a solid reactant and we are getting gaseous product. So entropy change is positive, right? So this statement is incorrect. We have to find the correct one. Equilibrium constant is greater than 1. So we have to see this one. Delta G is equal to minus 2.303 RT log of K. Right? Now if you solve this, delta G value is minus 350 into 10 to the power of 3 whole divided by minus 2.303 into 8.314 into temperature is standard temperature, that is 298 Kelvin, that is equal to log of K. Okay. So now if you solve this, okay, this value will be coming greater than 1. Okay. So now K value will be greater than 1. Okay. So this statement is a correct statement. You need not solve it. By seeing the values only you can tell. Now the reaction should be instantaneous, so that is not correct. The reaction has to be spontaneous, okay, not instantaneous. So this statement is also incorrect. The reaction is thermodynamically not feasible. The reaction is feasible because delta G is negative. So the correct answer for this question will be option number B, okay. Now let us see the next question. 5 liter of NaOH solution with pH 12 contains, okay. So this is very simple question. See, we know pH plus POH is equal to 14, right? Now pH is 12, so what will be the value of POH will be equal to 2. So that means the OH minus concentration is equal to 10 to the power of minus 2. Now we know NaOH concentration will also be equal to 10 to the power of minus 2 because from 1 mole of NaOH we get 1 mole of OH minus. So if OH minus concentration is 10 to the power of minus 2, NaOH concentration will also be equal to 10 to the power of minus 2. Now this one is equal to, so I can say molarity is equal to what? Number of moles by volume, or I can say given mass by molar mass by 1 by volume. So the molarity is for this one is 10 to the power of minus 2 into molar mass of NaOH is 40, right? And then volume is 5 liter. Right? So if we solve this, 5 fours are 200 into 10 to the power of minus 2, so that is 2 gram. So the correct answer for this question is option number D. Now next question, the pH of the solution having hydronium ion concentration as this much will be, okay. So if you calculate, we have this formula, pH is equal to minus log of H plus concentration is 6.2 into 10 to the power of minus 9. So that is equal to minus log of 6.2 plus log of 10 to the power of minus 9, right? So now if we solve this value, we will be getting around log 6 value. So if you remember, log 6 value will be coming around. So if you solve this one, we'll be getting around 8 minus 8.21. Okay, so the correct answer for this question will be plus 8.21. Okay, so that is why the answer for this question is option number D. So log, you have to remember the values of log 1 to log 10. Some important values you must remember. Okay, next question, when the solid potassium cyanide is added in water, then see, solid potassium iodide is water, KCN is there, what it will form, K plus and Cn minus, and in water what is present, H plus and OH minus. So what will happen, this H plus will combine with this HCl. So H plus concentration is decreasing. If H plus concentration is decreasing, pH will increase. So the correct answer for this question is option number A. Next, 4 acids A1, A2, A3 and A4 have the pK values as following. So A1 value is 3.75, A2 value is 4.75 and A3 value is 4.20 and A4 value is 5.72. Now you see, these are pKa values. If higher, the what is the formula of pK? pKa is equal to minus log of Ka, right? So that means higher the value of Ka, higher the value of pKa, lower will be the acidic strength. Okay, so pK and K are inversely proportional. pK is inversely proportional to Ka. So now the question is asking the weakest acid. The acid has to be weakest, means its pKa value has to be highest. If pKa value is highest, Ka value will be the least and it will be called as a weakest acid. So the correct answer for this question will be option number D, that is A4. Next question, when common salt is added to a saturated solution of soap, soap is precipitated. This is based on the principle of, so we all know soap contains the salt, so when you add this common salt to this, there is a common ion effect due to which the precipitation increases. So correct answer is option number A. Next, the solubility of AgCl at 20 degrees Celsius is given as 1.435 into 10 to the power of minus 5 grams per liter. The solubility product of AgCl will be, okay, so now you have to be very careful here with the units, that is grams per liter. We should convert it into moles per liter. So solubility is given to you as 1.435 into 10 to the power of minus 5 grams per liter. Now if you calculate the molar mass of this one, silver is 108, chlorine is 35.5, so that is equal to 143.5. So the solubility in terms of moles per liter will be 1.435 by 143.5 into 10 to the power of minus 5. So if I solve this one, we'll get 1435 by 1000 into 1435 by 10. So we can cancel here, we'll get 10 to the power of minus 5, 10 to the power of minus 7, right? So that is the solubility. Now the solubility product for AgCl will be S square, right? So 10 to the power of minus 7 square will be equal to 10 to the power of minus 14. So the correct answer for this question will be option number C. Okay, easy question. Next, the highest pH is exhibited by, highest pH value are exhibited by bases and low pH values are exhibited by acids. So these two are acids, we can eliminate them. Now if you see here, the OH minus concentrations for option number B will be 10 to the power of minus 2. So POH will be equal to 2. So pH will be equal to 14 minus 2, that is 12. Now if you see for option number A, okay, the OH minus concentration is equal to 10 to the power of minus 3. So POH value will be equal to 3 and then pH value will be 14 minus 3, that is 11. So the correct answer, highest pH, will be option number B. Okay. Next question, if the equilibrium constants of the following equilibria are. So we know whenever a reaction is reversed, the equilibrium constant is taken as inverse. When you multiply any number to the whole equation, that number power has to be taken as the equilibrium constant. Now if you see the first reaction, SO2 plus half O2 gives SO3, and the second reaction is 2SO3 gives 2SO2 plus O2. Now, so this value is K1 and this value is K2. Now, if you see K2, so how this K2 is obtained? First, the reaction was reversed, right? So once the reaction is reversed, you see SO3 is on this side and SO3 is on this side. So if I reverse this first reaction, so I will get what? SO3 gives SO2 plus half O2. Now, if you reverse this reaction, the equilibrium constant here will become 1 by K1, right? Now, the whole reaction is multiplied with 2, right? If you see, the whole reaction is multiplied with 2. So, if multiplied by 2, it will become power of 2. So, the 1 by K1 square. So, the correct answer for this question is option number A. Next question. A buffer solution has equal volumes of 0.2 molar NH4OH and 0.02 molar of NH4Cl. The pKb of the base is 5. The pH is what? Okay, so if you see here, the question is very tricky. This NH4OH and NH4Cl. NH4OH is a weak base. NH4Cl is a salt of weak base and strong acid. So it forms a basic buffer. So by Henderson equation, we have POH is equal to pKb plus log of salt concentration by the base concentration, right? So now if I substitute here, what is pKb value? pKb value is 5 plus log of salt concentration, you see NH4Cl, that is 0. So I'll write 2 into 10 to the power of minus 2 and this one is 2 into 10 to the power of minus 1, right? So I'll get here 5 plus log of 10 to the power of minus 1. So we will get 5 minus 1, that is 4. So this is pOH value, but the question has asked you to calculate pH value. So pH plus pOH is 14. We know this relation also, right? So if pH is equal to pOH is equal to 4, then pH will be equal to 10. So the correct answer for this question will be option number A. There is a chances since option number 4 is given. Once you get 4, you can easily directly will mark here. So you have to be careful in this question. Okay, now let us see the next question. For the following reaction, Fe plus H2O gives Fe3O4 plus H2. Find the Kp value, right? So the reaction, first of all, we have to balance it, okay? Once of all, like when you see, first is you have to balance the reaction. So we have Fe plus H2O gives Fe3O4 plus H2. Okay, so now if I want to balance the reaction, you see there is 3 Fe, so I'll add 3 here. And there is 4, so I'll add 4 water here, and there again I can add 4 H2 here, right? Now if you see, the Kp values are only considered with the gaseous reactants and products. So here water is gas and H2 is gas. So what will be the Kp value? Pressure of H2 to the power of 4 by pressure of water to the power of 4. So the correct answer for this question will be option number C. Now next question, in the hydrolysis of a salt of weak acid and weak base, the hydrolysis constant is equal to. So when there is a weak acid and weak base, we have Kw by Ka into Kb. Okay. So the correct answer for this question will be option number C. Okay. Now let us see the next question. If the solubility of an electrolyte is S, then what is the solubility product of the electrolyte of the type A3B2? So this one already I have discussed you. If you have the formula of A to the AXBY salt, then the KSP value is equal to x to the power of x, y to the power of y, s to the power of x plus y, right? Now in the given question, this is my x, this is y. So x is equal to 3 and y is equal to 2. Now if I substitute the values, 3 to the power of 3, 2 to the power of 2, s to the power of 3 plus 2. So 3 3s are 9, 3s are 27 into 4 into s to the power of 5. That is 108 into s to the power of 5. The correct answer for this question will be option number C. Now let us see the next question. Which of the following is a buffer solution? So here you should remember about buffer solution. There are two types of buffer solution. One is acidic and one is basic, right? So acidic buffer solutions are made up of weak acid plus salt of weak acid. Okay. Salt of weak acid and strong base. Now, for example, I'll take a weak acid like CH3COOH and the salt of this one with CH3COOH plus NaOH, that is this two combination. Now similarly, a weak base or a basic buffer is made up of a weak base plus salt of weak base and strong acid. For example, NH4OH is a weak base, and we have a salt of NH4OH plus HCl, that is NH4Cl, right? So these two can form a basic buffer. So that is why the correct answer for this question is option number D. Now let us see the next question. Which of the following equations give ionic product of water? So ionic product of water, what is the equation? 2H2O gives H3O plus OH minus, right? So now if you see the equation 1 and 2, if I add the equation 1 and 2, okay, I will write here separately first, it may not be visible. NH3 plus water gives you NH4 plus OH minus, and equation 2 is NH4 plus water is giving you H3O plus NH3, right? Now when you add these two equations, okay, you can see NH4 can get cancelled, NH3 will get cancelled. We have 2H2O is giving you H plus, H3O plus and OH minus, right? So that is the equation here. So correct answer is 1 and 2, that is option number C. Okay. Now let us see the next question. The number of H plus ions present in 1 ml of a solution of pH 13. So pH is 13 means, so if you see here, H plus concentration will be equal to 10 to the power of minus 13, right? Now 10 to the power of minus 13 molar. So what does that mean? We can say in 1000 ml, or that is 1 liter. Okay, molarity is what? Moles per liter. So in 1 liter, there is 10 to the power of minus 13 H plus moles, right? That the question is asking for 1 mole, sorry, in 1 ml. In 1 ml, it will be 10 to the power of minus 13 by 10 to the power of 3. That will be equal to 10 to the power of minus 16 moles, right? Now, we want to calculate the number. So this many moles means how many Avogadro number? 6.022 into 10 to the power of 23. So 23 minus 16 will be equal to 6.022 into 10 to the power of 7. The correct answer for this question will be option number B. Okay. Now let us see the next question. Delta G for the conversion of O2 is given. So you have to find the value of delta G. Okay. So this is very direct formula. Delta G is equal to minus 2.303 nRT log Kp, right? Just substitute all the values. N value is 1, R value is 8.314. You can see the units are in joules. Then temperature is 298, and then log of Kp is 10 to the power of minus 29. That 29 will come here. So we'll get 2.303 into 1 into 8.314 into 298 into 29. So if you solve this value, you will be getting around, so divided by 1000 we will do, because kilojoules are there, we will be getting around 165.4. So the correct answer for this question will be option number B. Now let us see the next question. In which of the following case the reaction will go fastest to the completion? So if you see, Kc is what? Concentration of product by concentration of reactants. So if Kc value, if the product concentration is more, then the reaction goes towards the completion. So if you see in all the values, 10 to the power of 2 is highest, that means more products are formed, so reaction is going towards completion in option number A. So correct answer is A. Now next question. 1 mole of PCl5 is heated in a closed 2 decimeter cube means 2 liter vessel. At equilibrium, 40% of PCl5 is dissociated. Calculate the equilibrium constant. So now if you see here, PCl5 will dissociate to give you PCl3 plus Cl2. Now this is equal to 1 mole. Okay, initially it was 0. Now 40% has dissociated, means 0.4 has dissociated. This was initial concentration. Now final concentration. If 0.4 moles has dissociated, then how much will be left? 1 minus 0.4 has dissociated, right? Now 1 mole is giving you 1 mole, so 0.4 will give you 0.4. So this one will also be 0.4, this one will also be 0.4. So final concentration will be 0.6, 0.4 and 0.4. Now what we have to calculate, the equilibrium constant is equal to concentration of PCl3, concentration of Cl2 and concentration of PCl5, right? So PCl3 will be equal to, so vessel is also 2 decimeter cube, so we have to keep the volumes also. So it is 0.4 by 2 into 0.4 by 2, and then we have in the denominator 0.6 by 2, right? Can just cancel 0.2, then we have here 3, so 0.4 by 3, or we can say 4 by 30. Okay, so the correct answer here we will be getting is option number C, that is 0.133. Okay, so now let us see the next question. Accumulation of lactic acid, a monobasic acid in tissue, leads to pain and feeling of fatigue. In a 0.1 molar aqueous solution, lactic acid is 3.7 dissociates. The value of the dissociation constant Ka. So we know Ka is nothing but C alpha square. So C value is given 0.1 and alpha is 0.37%, right? So that means, sorry, 3.7%, that means 0.037, that is 3.7 by 100. So we'll get 0.037. Okay, so now if you multiply it, the value will be getting around is 1.4 into 10 to the power of minus 4. The correct answer for this question will be option number B. Okay, now let us see the next question. At 100 degrees Celsius, the Kf of water is 55 times its value at 25 degrees Celsius. Then what will be the pH of the neutral solution? Log 55 is 1.74. Okay, so this is little interesting question. So you know what is the at 25 degrees Celsius, what is the value of Kw? That is 10 to the power of minus 14. At 100 degrees Celsius, the question is asked, it becomes 55 times of this one, right? So what I can write, Kw at this point is 55 into 10 to the power of minus 14. 55 times of this one. Now what is Kw? Kw is the concentration of H plus into OH minus, right? That will be equal. So I can write Kw is equal to H plus concentration square. Now what is Kw value? 55 into 10 to the power of minus 14 H plus root over. Okay. Now if I take log on both sides, right? So we'll take log of 55 into 10 to the power of minus. So I'll write it in this way. 1 second. So we can write it like this. 55 into 10 to the power of minus 14 to the power of 1 by 2 is equal to H plus. Now taking log on both sides. So 1 by 2 minus log 55, negative logarithm on both sides, minus log of H plus, that is nothing but pH. So just you have to solve, the value is already given 1.74. So once you solve this, we'll get 6.13. Okay, the correct answer for this question will be option number D. Now let us see the last question. The dissociation constant of a weak acid is 1 into 10 to the power of minus 4. In order to prepare a buffer solution with pH 5, the salt to acid ratio should be equal to. So very easy question again from Henderson equation, acidic buffer. So pH is equal to pKa plus log of salt concentration by acid concentration, right? What is the value of pH given? pH given is 5. Okay. Now pKa value is what? Minus log of Ka, that is equal to minus log of Ka value is 10 to the power of minus 4, that is 4. So now we can substitute here 4 plus log of salt concentration by acid concentration. Okay. Now if you see here, we'll get 1 is equal to log of salt by acid. So that ratio will become antilog, if you take 10 is to 1. The correct answer for this question will be option number B. Okay. Yeah. So yes, we have completed top 30 questions from the equilibrium chapter. Almost all the concepts have been covered except Lee-Chatterley principle. So just you can revise some questions or some concepts from Lee-Chatterley principle, that is also important. And if you have any doubt in any question, please comment down. I'll be definitely replying it, or I'll address it in my next video. And if you have found this video helpful, please like, share and subscribe our channel. We are producing many videos now based on your COMEDK preparation. So please join the channel. That will definitely help you for your preparation. Thank you and all the very best for your exam.